All right. Hi, everyone. This is Kerim Baran with SolarAcademy. Today, I am here with Jayson Smith from CPS. As you might have seen in a previous conversation, we talked quite a bit about CPS and their strong position in the US market when it comes to inverters and related solar equipment. But today, we're going to talk a little bit more deeply in CPS's utility and ESS product solutions. However, before getting in there, Jayson, I'd like to talk a little bit about your background, how you found yourself in the solar and renewable energy space, and specifically at CPS. Feel free to go back in your personal history of, how your academic and professional career started and evolved, and here we are.
Definitely. Yeah. Hello, everyone, and thank you for Kerim for inviting me to sit here and have a conversation with you. So a little bit about myself. So I got my degree in mechanical engineering from Texas Tech University. It's actually kind of funny because all I work in now is electrical engineering. So I don't know why I went with mechanical. But
and you're a guy from Houston.
Yeah, and I'm in Houston.
The home of the oil industry, and yeah.
I know, right? Yeah. Why am I in renewables? Crazy. So right whenever I graduated, I went to work for a company by the name of Innovative IDM, and that's where I kind of cut my teeth, if you will, on the electrical industry. So that company, we had a large focus in industrial electronics. So on a daily basis, I would, be going into these manufacturing facilities and, looking at AC motors, DC motors, variable frequency drives, maybe their HMIs or their PLCs, which are programmable logic controllers. So I got kind of a really good basis of understanding on electrical systems then, and really enjoyed working for them. We even manufactured some full electrical cabinets and whatnot. So really got like a good idea of looking at, single line diagrams and things like that. And then from there, I actually transitioned over into renewables with Q cells. So what ended up happening there is I had a good friend that I had worked with at Innovative IDM, and he was like, "Hey, you know what? Let's be slightly better people and work for a renewables company." So I was like, "All right, well, let's do it." And I started working for Q cells. And there, I was a field applications engineer. So
and you're in the module business of Q cells, I assume.
not on the module side. So it's
Oh.
actually interesting. Yeah, Q cells has a battery division as well. And if you look at the topology of an inverter for a battery, or even for a PV inverter, the topology is just like the topology that you find in a variable frequency drive. Now, there are a few different things here and there, like one uses MOSFETs, while the other one uses what we call IGBTs, but that's kind of getting into the nitty-gritty.
Yeah.
But overall, the bridge structure is fairly similar. So whenever I started working for Q cells, I kind of had a pretty good idea of what I was getting myself into. But as a field application engineer for them, my main thing was usually going out and fixing these sites that for some reason were having issues, or providing technical trainings for people who would be working on those sites, and so on and so forth. So I got a really good kind of look at the solar industry as a whole, working with them. Now with them, I worked mainly on what we would call split phase, or residential type of systems. So after working with them for a while, I realized, well, I kind of learned a lot, and I think I'd like to go into something that's a little bit higher power. And that's actually where CPS came along. So I've been with CPS now for, I want to say 9 months or so, just shy of a year. And with CPS, I now focus heavily on the CNI and utility scale ESS systems that they have. Now, we actually also have a split phase system as well, or residential, whatever you'd like to call it. But I try and shy away from working on that one. I like the big stuff.
So with that, maybe I should share my screen, the PowerPoint you shared with me, to talk a little bit about CPS and its history. I remember having run a solar equipment distribution company in the early 2010s. about a dozen years ago is when Kyle Cherrick and team was introducing CPS to the market back then. I don't know if you know Kyle, who's doing a bunch of
Do
other
you know
things.
Casey? Do you know Casey?
I
He's
remember a
now with
name
Alexity.
Casey, but I don't I can't put a face
Gotcha.
to the name right
Yeah,
now. But
he was one of those OGs as well. So
yeah,
really good guys, really good guys. But
yeah.
yes,
And
if you
I
want to
do
go to
remember CPS being really strong in the CNI space, but now I think like I'm recently learning about its massive footprint all over the world and Asia
oh
and the massive
oh man,
products. And so yeah,
yeah.
let's talk a little bit about that. So yeah, we'll talk about the energy, the battery and energy storage systems, but let's talk
Mhm.
for a few minutes about CPS in the world. So
Definitely, yeah.
yeah,
So to kind of give you an outline of what it
yeah,
looks like, so Chint is our parent company. So
hmm,
they own CPS America, right?
yeah,
Now Chint has been around since I want to say 1984,
yeah,
and the entire time they've been around, it's been focused on electrical equipment and heavily in renewables.
yeah,
Yeah, this diagram that you're showing right here is a pretty good representation of just how massive the company is. They're
hmm,
everywhere, literally everywhere. I
yeah.
mean, half of the people listening to this could probably go to the loads panel in their home and open it up and find a breaker that Chint makes. A couple cool
And it says
things.
according to Bloomberg NEF, Chint or CPS is the number one bankable inverter brand in the world, I guess, as of
That
last year.
is Yep,
That's,
that is accurate. That is accurate. And
yeah,
actually, CPS America has been the number one PV string inverter for the last handful of years, 7 or 8, something like that. Been the number one. So
yeah,
a rich history in PV inverters and specifically the string design of PV inverters. We don't do central, so we've actually taken that success and we've moved it
hmm,
over into our battery system, which we'll touch on here shortly. Yeah, so right here is essentially what we have for our battery offering. So that top bit is going to be our 5 MWh best container. So that's going to be a 20-foot HC standard container. And
hmm,
then that 2.4 megawatt string skid is also 20-foot size. And that's going to be what's actually doing, the DC to AC, AC to DC. That actually comes with a transformer on it, which is
hmm.
super interesting and something we can talk about a little bit later when we get to kind of the dynamics of the market and some of the pain points that people are seeing right now. We're
Yeah.
actually able to kind of get around a couple of those pain points because we will incorporate all of the balance of systems into that skid for you. So that skid is comprised of those 200 kilowatt PCSs.
Hmm.
So to explain this a little bit further,
Should I
yeah,
go to the next slide now? Yeah,
yeah, go back real quick.
yeah,
Yeah, right there. I was just going to say to explain that we can dig in and talk about how that actually connects to the battery later, and
hmm,
how that gives you that string design. On the bottom is our CNI, so our smaller scale, which you can see we have the 125 output and the 250 output, and those
hmm,
are also very interesting. When you get to the 250, you actually get into a bit of a string design there as well. So, like I said, we're taking all that knowledge that we got from the PV string inverters and we brought it over into our battery system. The goal being easy installation, quick commissioning, and less downtime in the long run. I did a white paper the other day um, that was like a central BESS inverter versus our string design. And if you run it out for a 20-year lifespan, well, if
yeah,
you run it out on a 20-year lifespan, you see that if there's 1 or 2 instances of failure, really you just need 1 instance of failure from that central inverter to make it not worth your money versus a string design system. So a lot of people are like, oh, well, string, PCSs are going to be more expensive. They're really not, but if something were to happen, you're only losing one little bit of your output. You're not losing your entire BESS container. So super interesting.
Yeah, let's dig into that. And essentially, like this product line, these product lines on the utility side, the 5 megawatt hour LFP container and the 2.4 megawatt hour skid, and the CNI products are essentially your day-to-day responsibility areas as a solutions engineer. So you talk about these solutions and their key benefits all the
Every day.
time, I assume. So yeah, let's dig into those key benefits. I guess this slide is where we can start digging in a little bit more, huh?
Yeah. So I put this slide in here to kind of give a reference point of what a normal installation might look like. Obviously we have our PV inverters, our breaker box fuses, all that stuff, even medium voltage transformers. That's all going to be on the PV side. But the main thing I want to point out here is that point of interconnection, which I kind of alluded to this a few minutes ago when I was talking about some of those pain points that people are seeing. Those pain points I was talking about was the transformers. So with our PCS skid, you get a built-in transformer. And that transformer can be 12 kV to 34.5, right? So whatever you essentially need it to be, we can make it. And we can get you that in 6 months, when most people are finding that transformers right now, you can't get for 9 months or a year. So that alone is kind of a huge benefit that we're seeing. Has actually been really nice for us and our customers. But with that ability, we can pretty much interconnect wherever you want us to, right? Since we have that wide range of outputs. So that's really what I wanted to showcase right here. And then also you see that there's 2 battery containers going to 1 PCS skid. So that's what we would call our 4-hour model. So 10 megawatt hours of capacity and 2.4 megawatt max output. That actually can be increased a little bit, but for all intents and purposes, 2.4 megawatts of output right there. And obviously we can derate that as well if we needed to. But this is kind of a standard looking design that we would see on some of these larger scale systems. This is similar to what we just saw for the utility, but this one's going to be focused on the CNI. You can see this one's behind the meter. So the CNI system has actually been fantastic for us. We actually had an older, smaller battery system that we sold for a little while, but we've moved on to the 125 250 now. And then we obviously have some stuff coming out in the future, which I won't touch on today. But just some nuggets for you guys, What you're seeing here, though, is going to be kind of a standard setup. Obviously, with CPS, we can provide a large majority of this. In fact, the only thing that we can't provide, I would say, is the diesel generator or your loads. So on the solar side, obviously we have our PV inverters, and we actually have a sister company, Astro Energy, which makes PV panels. So that they're also owned by Chint. So you can get that all from CPS or our sister company. And then the energy storage system, obviously, like we're talking about today, is going to be from CPS. One cool thing, though, that we've done on our CNI system specifically is we have a partner called Alexity that we work with for our EMS system. Now, I want to make it very clear that for the energy management system, we are agnostic. We have a local controller in the backside of our PCS cabinet that you can hook up any energy management system that you want to, and basically gather that data, control the system, whatever you need to do. However, we've realized that in the market right now, a lot of people want a one-stop shop, right? So we provided that through our partner Alexity. And we can talk about some of Alexity stuff later. Very interesting company. They have some great different things that they can do with their system as far as controlling loads dynamically and whatnot. It's just super, super cool stuff. But as I was saying, in this scenario right here, you could, from CPS, you can get our PV inverters, you can get our energy storage system. From our sister company, you can get the PV panels. Go somewhere else for the diesel generator. That's about it. But we can even do, so this is showing what we would call a grid tied system, right? In this scenario, standard 125. Most of the time, this scenario would be used for basically peak shaving or shifting of your high demand. You actually see
Yeah.
this a lot in California now. So we have a couple sites and scenarios where people have like a large building and they've had a decent amount of solar panels put on it, say in the past, right?
Mhm.
Well, now with NIM 3, all these new projects, even some of those that were just finished up, they're not getting anything when they're selling their
Yeah.
back to the grid.
Yeah.
Yeah,
Well, I mean,
it's
hopefully they got live back in NEM1 or NEM2 days, and
that's what you're hoping.
con-
But if you
those con
didn't,
yeah, if you miss that window and you have to finish it in NEM3 rules, you're a
that's
little bit out of luck and
oh yeah,
monetizing that. So you
which
definitely need to integrate batteries now to make best use of your electrons.
it's
Yeah.
crazy because I didn't put a slide in here. I should have that shows a graph of it's kind of like an estimated graph of what your energy buyback price would be under
Right.
NIM 3
Oh yeah, yeah.
and
It's a small fraction of what
it's
you were getting before.
it's atrocious.
Small.
I mean,
Yeah,
there are times
yeah,
when you're not. I mean, you're getting a tenth of a cent. And it's like, okay, well, I'm
yeah, yeah,
basically
yeah.
it's
Right.
basically costing me money, at
But
that point.
you can't blame the utility companies for that because they're they're they have so much supply of energy in the middle of the day when solar is
Yeah,
cranking, and
yeah,
so it's kind of like those COVID days when we didn't have any place to put the oil coming in with
yep,
tankers, you know, it's kind of
yep.
it's kind of that same dynamic. But
You're
so
exactly right.
yeah, so going back to the slide, you're talking about the EMS, the PCS, the
Hmm.
BMS. Like
Hmm. Hmm.
I vaguely know what these terms mean, but for some of
Okay.
our viewers, can we do a little bit of education of like what they all stand for and what how they
Yeah.
all work with each other and where they are. I know the EMS sits here, but where
Yes.
in this picture does the so and EMS stands for
Energy
energy
management system.
system, and then
Yep.
there is there's the battery management system BMS,
Yes,
and
that's
then
the
there's the
BMS.
PCS, which is the power conversion system.
Correct.
And I
So
assume the BMS sits right on top of the battery
yeah, it's in that
as an
yeah, that battery
interface.
container. Yep,
Yeah.
yep.
And
So
then
it's sending
the PCS goes where in this picture?
so it's yeah, the little one just to the left. No, go back down to energy storage system.
Oh, right
So it's
here.
right there. So that
Yeah,
inside that cabinet is where your
yeah.
PCS lives.
And that
So
is where your AC/DC conversion is happening.
correct. That is
Yeah,
correct. Yep.
yeah.
And now so how it really looks is the BMS is
But
controlling your battery.
so how is that AC/DC conversion different than the traditional string inverter for a solar system,
Yes.
array of
Yep. Yep.
solar?
Yep. Okay. So it's actually it's in the name. So
Yeah.
inverter technically refers to a one
Oh,
direction.
yeah,
So we're
AC to
going from
DC. I
DC
mean DC to AC. So
DC to
it
AC.
inverts the
Yeah,
DC coming from the panels into AC
precisely.
that is in sync
Now
with the grid. Yeah,
now we call a PCS a power conversion system. We call it a PCS because it can
yeah,
go both ways. So we
got it.
can
Yeah,
go DC to AC, AC to DC to charge the
yeah,
battery. Yeah,
yeah,
yeah.
yeah.
So in
Perfect.
simplest terms,
Yeah,
yeah,
got it. All right. Thank you for that clarification. So
yeah.
yeah, and that got it. So what are some other like unique differentiators for CPS in the market today as we look at this system and also the utility system that we were talking about before this, so the utility solutions. And I don't know if I should go back to those slides or kill the slides and just talk
You
face
can
to
just
face
kill them.
about that.
Yeah,
Yeah.
yeah.
So like what do you when you're making your sales conversations or post sale
Hmm.
support, like
Yeah.
what are the times you say, oh, thank God we do the things this way because it creates a lot of value for the customers?
Gotcha. Gotcha.
Yeah.
Yeah. There's a couple things. I'd say number one hands down, by far, the biggest thing for CPS, other than our own brand, is going to be our service. So Chint has just been known throughout the years to have, tier 1 service on everything. And we've taken that, from our PV inverters and brought it directly over to our BESS as well. So whenever somebody messages us and says, even from the, beginning cradle stages of a project, they message us and they're like, hey, I need help on XYZ. It immediately is going to come to an engineer, me or one of my coworkers, and we're going to start working with them, helping provide information. The only thing that we won't do for you is I'm not going to sign an SLD for you. I'm not a PE, right? Other than that, I'm going to help you through every single step of the project. And then once that project is on site, I can be there to help you commission it. And then once it's commissioned and running, through our Flex OM, we can sit there and help you monitor it. And then throughout the lifespan, if anything happens, you can call us. We even offer long-term service agreements that we can do to help you out, help the customer out. So I'd say one of our biggest things is that from cradle to grave, we are there and we are a contact. And every time you call, you're going to get somebody who 9 times out of 10 has some type of engineering degree or even a master's or a doctorate degree. So that's
so you're almost
crazy,
like
but
a service company as much as a product company. Do you charge
100%.
for the service as well as a separate line item, or is that integrated into the product?
So
Revenue?
obviously all of our stuff comes with a standard warranty, right?
Yep.
You can increase that warranty, and then you can also add a long-term service agreement on there. In addition to that, though, we're pretty nice people. Okay. So if you're having an issue and you need some help, you can definitely call us at our hotline, and then we'll provide, some information or let you know where you need to go to figure something out. So we're pretty open with, helping individuals, but we do provide that long-term service agreement at a charge. Yeah.
Got it. Great. What other key differentiators for CPS can we bring up in this conversation? I remember in our previous conversation, you mentioning the string design being a key benefit with the multiple cabinets. And I assume, can you tell us a little bit about that in the context of utility scale solutions and CNI?
Yeah, definitely. That's what I would call the other big differentiator. So like I mentioned before, with the string design, you get redundancy. So essentially how that looks for the utility scale is inside that battery container, you have different racks of batteries, right? Each rack is controlled by its own individual PCS. So if you're looking at the very bottom right, you see there's like the couple little green lines going. What that's trying to denote is that you can see the individual racks in the BESS container, right? Each one of those racks goes to its own PCS. So if something were to happen for some reason and one of those PCSs has some type of issue, you're not losing your entire 5 megawatt hours. All you're losing is that one 200 kW output. So that's massive, right? That's huge, especially when you get a lot of these things together. The other benefit,
that's kind of like the microinverter effect in a residential installation.
That's exactly it. That's it. Well, and just like how microinverters are really easy to go and swap out, we've made these really easy to go and swap out. Literally, all you have to do is if one goes out, you would go up to it. You would obviously turn off the disconnects for that PCS. You unplug, I want to say it's 3 cables on the back, 2 cables on the front, plus a comms cable. Slide the whole thing out, slide a new one in. You can do it in, I don't know, 30 minutes, an hour.
These are the components we're talking
those
about.
are, so those, we're seeing the racks there. There's 8 modules per rack. And then this actually shows a little bit more as well as far as our viewing structure. So one thing that's really nice about how we have this set up is we want to get as granular as we can, right? We want to see everything. So inside each module, we have CSC sensors. So essentially what that means is we can see individual cell temperature levels, voltage levels, everything like that. That data is then taken and it's brought down to, that would be the BMU. And then that's brought down to our, what we call our BCMU. And all these acronyms, don't worry about them. Essentially what I'm trying to tell you is that from our module level view, we can take all that data and put it and say, okay, this rack with these 8 modules in it is doing this as a whole, right? And then that goes over to our actual battery management system, which is talking with our PCS and the EMS. And essentially we can control everything at a much finer level, and we can see if there's any issues going on, and we can correct any differences in state of charge between cells and modules. So that ability not only helps us make sure everything's up and running right, but we also have the ability to increase the lifetime of the battery system because we have that granularity and that ability to control an individual rack. With like a central, you're just pushing power to this block, right? Now we've essentially cut up this block and push power to this one, this level, and make sure everything's even all the way throughout. So big
and that
benefits.
probably ends up mitigating the total downtime of a battery system in its lifetime too, because worst case, you're not down for a day or 2 days or hours, but you're just down 2% of the whole battery system for a day.
That's it.
So that ends up being like still 99.5%.
Exactly. And that's where the big cost savings come in. And a lot of people, for some of these large like utility scale installs that we do, they'll buy a couple extra PCS units just to keep on site. So they can swap it out immediately, send us the old one, and for under warranty, we'll fix it for free, right? Send it back to you.
That makes sense. How about in the CNI segment? So does this same logic transfer over there, and what are some other elements that come into play?
So it does when you get to like the 250 system. So
should I pull up a slide again?
You can, pull up that number 3 slide, or this one. It actually works well. That one right there is fine. Okay. Let's look at this one. Okay, so just to put it out simply, so what we're looking at here is going to be the front side of the PCS cabinet. In the PCS cabinet, you see denoted right there, there's 2 125 kW PCSs. So each one of those will control its own battery cabinet. So for the 125, when there's only one of those 125 PCSs in there, and then you only have one cabinet, so you don't really get the benefits of the string design. It's just because it's so small, right? But when you move up to that next step, to the 250, now each 125 is controlling its own battery cabinet. So if one of those goes down, you still have the other battery cabinet. You see, so it gets, we still have that implemented. It's hard to implement it on a really small system, but we still do have it implemented once you get to that 250.
I assume you can design solutions at multiples of 125 kW for a CNI application. Like you can do a 500 kW system probably as well as a megawatt or 375.
Definitely.
I don't know if that's possible.
And that gets into like you can parallel, right? So we would have, say, like this setup right here is the 250 setup. So you'd have this PCS and then a battery cabinet on one side, battery cabinet on the other side, or however you want to configure it. We could add the exact same thing next to it, parallel it all together, and run that all to a single EMS that's doing the high level control of everything. And we can do that up to 8. We can have 8 of them together whenever we're grid tied. Now, there are some nuances there. I will say, whenever you get into the microgrid that goes down. You can only put 4 in parallel, but that gets into loop currents and, more technical type stuff that I don't think we necessarily have time for today. But
Makes sense.
but to answer your question, you can put quite a few of these together and have it run
Yeah.
that way, depending on how much, capacity you need.
Yeah. There was also the point about isolation transformers coming into
Yes.
play in these designs. Can you tell
So
us a
that,
little bit about that too? And then the
yeah.
480 volts playing into it
Mhm.
also.
Yeah, which I'll keep it all high level.
Mhm.
But essentially what I was talking about with that when we spoke previously is whenever you are doing an install where you want to be able to have a microgrid, so where you're independent from the grid itself,
Yeah.
you're gonna need an isolation transformer. And the reason for that, so our system and pretty much every other CNI system out there outputs
Mhm.
a 480 delta. So essentially the output, looks like a triangle, right? If you were to draw it out. With that, there's no neutral point. So you need what we call an isolation transformer, which in most scenarios would be a delta to Y. That way, so the primary side would be delta, the secondary side where your loads are would be a Y. And you do that way you can create a neutral for your loads. So that is a requirement
That
if you're
that
trying
is
to do a
a
microgrid.
that is why it's three phase. Is that kind of like the the difference between three phase and single phase systems in
No,
Resi versus CNI? The
no.
whole
So Resi is a different beast.
uh,
Resi is a split phase. So you can actually look at it as a Resi output would be like line 1 and line 2, essentially, and then CNI would be line 1, line 2, line 3. So
right.
it's different. It's definitely
Okay.
different.
We don't need to explain it
Technically
all now.
speaking, I mean,
Yeah.
technically speaking, if you look at a transformer,
Yeah.
all it is 3 single phase transformers put together to a common iron core. We can get really deep into it if you want. I don't know how much time we have, but um,
Well,
yeah, split phase
maybe we'll do that
is gonna be
in a
different.
separate conversation. Yeah.
Yeah,
But
let's do that. Let's do
yeah,
that. Yeah.
going back to the topic in hand of you know why an isolation transformer is needed in the more
Mhm.
CNI applications.
Yeah, and the short answer to that question is we're creating a neutral. We're creating a neutral point.
Yeah.
Yeah. Yeah.
And so when you look at the market today, like where do you
Mhm.
see most demand and what kind of applications and
Yeah.
geographies and types of customers are demanding your utility and CNI type solutions?
I mean, there's a ton of different scenarios that we see. I'll start with saying that, but some of the really common ones, it's actually it's interesting because geographically speaking, things change. Um,
Yeah.
but like we'll take California because we were talking about California earlier. With California, because of NIM 3, we're
Yeah.
seeing a lot of people put in batteries there to capture that excess PV. And
Yeah.
then so they'll charge essentially the graph would look like, okay, high PV, in the middle of the day. So they're
Yeah.
creating enough power that they're getting rid of their loads and then they have excess. So we throw a battery
Okay.
system in there so that way we can charge during that peak PV production, and then we'll discharge that battery when that demand is still high between say 6 p.m. to 9 p.m. or somewhere in that range, further reducing their demand charges, right? Because that's really what's killing people. I mean, you
Yeah.
have some of these businesses where 75% of their electric bill is because of some 15-minute demand peak.
Yeah.
I mean, it's crazy. It's crazy. So
Yeah.
having that battery there,
Like a church Sunday morning is crazy. And they do get those demand charges actually. Like, and then
yep,
the rest
yep,
of the week it's just quiet then in there.
yeah. Rest of the week's
And
nothing.
yeah,
Yeah,
it's a
that's
unique use case, you know.
that's exactly right. That's
Yeah.
exactly. We had an installation the other day out in California, out by the Chino area. It was a school, and So we did our system with the Alexity EMS, and they had some solar and whatnot on the roof. And through our financial models, which we work with Alexity, so like engineering tool base, how they'll do a financial model. Well, we can actually do the same thing with Alexity. I should say Alexity can do the financial model, knowing our system and everything. So we did this financial model.
You're referring to the modeling of the return, kind of like the energy tool-based solutions.
Precisely. That is exactly right.
This is all to like offset that duck curve we were referring to. And talking about the duck curve, I just wanted to share this from the solar charts section of SolarAcademy. This is California's duck curve and how it evolved from 2015 to 2023. Like this is the effect of solar, essentially, just
But you're still seeing that 6 to like 9, 10 p.m.
Yeah, of course.
And
that's crazy.
That part will still get you. Like I said, what we've done.
You're seeing this in a residential setting or in like a commercial business setting?
Commercial, whether it be, an office, a hospital, a school, manufacturing facility, anything like that. You're seeing
they have 2 shifts and they go till 9 or 10, and that evening hour is still crazy there.
Exactly. And through what I was getting at, through our calculation, the payback for our system, plus the Alexity EMS, is like 3.5, 4 years. Like that's a super fast payback for a system that's going to last 20 plus years. So I mean, at the end of the day, it's like, all right, well, I'm saving a lot of money, by implementing this, which is fantastic. And Alexity actually, they're amazing. I said earlier that I'd speak a little bit on this. They have the ability to actually control your HVAC unit as well. So HVAC units, they account, especially in like Texas and Southern California, they account for like 80% of your overall demand charges. I mean, because whenever those things kick on, it's power, So they have the ability to take that and essentially make a thermal battery out of your office. So you can set a window to say, okay, this is my comfort zone. So whenever it's the middle of the day and your solar's going, you
just make it cold.
You make it cold, and then once that 6 p.m. hits, then you slowly go from that cold up, right? So instead of it just kicking on immediately and you get in that high charge, so that coupled with our battery, I mean, you're sitting pretty. So it's really interesting to do the calculations to see just how much you can save.
Right.
The EMS itself is fantastic. Yeah,
it's incredible. I was talking to a colleague in another conversation how the city of Cambridge, Massachusetts used to run on DC electricity 100 years ago. And also about 100 or 80, 60 years ago, companies had a VP of electricity, the type or VP of energy for the company to optimize and I feel like we're moving back towards those trends. A lot of DC production happening behind the meter, behind the transformer, on the side of the consumption, and also a lot of like optimization opportunities are going to come with that. And so we're going to have like mini managers or maybe VP managers of energy. And large companies like the big tech companies obviously have huge departments that deal with in that. But I think that might become a more common thing even for medium-sized commercial and industrial assets.
No, I completely agree with you. Yeah, I completely agree. I mean, it's you can save so much money by putting a little bit forward, essentially, is what we've noticed. And you also have those scenarios though where like the grid, we all know that the grid isn't what it used to be, is a good way to put it. It's just not able to provide the power that everybody necessarily needs. So we're even seeing that like from these electric providers, where they're starting to install some of these large, PV array fields with batteries. So that way their old transformers that they have, which have been getting overloaded for these, these towns, they're not having to put the stress on them that they used to, because you can interconnect, on the secondary side, right? Going straight
Oh,
to, yeah,
so bypassing the old transformer, you mean?
So essentially, yeah, you're injecting power to take the load away from that transformer. Yeah.
But you're
Yeah.
still going through that transformer when you inject the power, right?
Well, okay. What I'm talking about is from their power plant, right? You have your transformer that's, say you have one that's shooting out 34.5, right?
Yeah.
Well, we can come in and we can plop our battery system and our PCS unit down there. We can connect to that 34.5. So then that transformer that's at the power plant isn't
Yeah.
having to take all that load, because
Yeah. Yeah.
we can
Yeah.
inject
Got it.
you see what I'm saying? Yeah.
Yeah.
So that's another thing that's been happening. Just
Now you,
so it's so expensive to put in new equipment everywhere, and I mean, running
right.
highline wires is not cheap. So
Right. Yeah.
I mean, that's another scenario that we're seeing a lot of, which those ones are fun. I mean,
Yeah.
they're bigger scale. So, uh, but yeah,
Yeah. So
that's
I
stuff
guess
all over
we're
the
in
place.
agreement that a lot of production growth, I think, is going to happen on the other side of the transformer and the meter as
Oh
we
yeah.
move into this century. And so what other application, like what other settings are you seeing this demand in, like besides factories? CNI in California is a whole other story, obviously.
Mhm.
Are you seeing in other geographies? You mentioned some of the flyover states being
Yeah.
overloaded, and
Yep.
um,
Yeah. So
uh,
yeah, Midwest, like I said, that so you've actually seen a large influx of people moving there, and like, even, I don't know if you consider Texas a flyover state, but even Texas, maybe parts of Texas, I can tell you Lubbock, you can just fly right over that place.
Texas
Um,
is the number one solar state now, I think,
it
right? Or
is, man.
number
It
two, if it
is.
is not
It
number
is.
one. Yeah, yeah,
Um, um, yeah. So if you group Texas into that, like I was saying before, you've gotten to where all these people have moved to these new places, and the amount of people requiring power there has increased so much that the existing systems just can't handle everything. So
yeah,
that's where we're coming in, and we're supporting these utilities by installing these massive PV farms with battery systems to capture some of that excess PV whenever maybe the demand's not quite as high, but it's still pushing power. And then that best unit can discharge at some of those peak times later in the afternoon. That's a big thing that's going on. Like I said, through the Midwest, definitely in Texas. Texas has been just booming
yeah.
with install. I mean, it's crazy. It's crazy. In addition to that, there are a lot of like manufacturing plants that are getting into the same idea, because there's a couple areas where,
This is
because
outside of California you're talking about, right?
outside of
Manufacturing
California.
outside of California. Yeah.
Oh yeah. Some of these, okay, so for instance, in Texas, even if let's look at the really small scale. So in Texas, on the residential side,
Hmm.
you can get a pretty good cent per kilowatt hour when you're pushing power back to the grid. So because of that, um,
Is that like more similar to the early NEM 1.0 rules of California, where you would essentially get credited back at your highest consumption rate, no matter what time you produced, as long as you fed it back into the grid, they would start deducting the, or they would start crediting you for everything you exported at the highest consumption rate that was
oh
reflected
yeah,
on your bill. And
oh yeah,
I did that 10 years ago on my first solar installation on my previous home. I got a 3.5 year payback on a
oh yeah.
really
That's it.
nice solar system. That was just amazing deal. Yeah.
That's it. Yep. So Texas
So
is
is Texas
similar.
in that stage right now? Like, because
I
I think
wouldn't
that
say
makes
it's that
sense.
good.
I would say that makes sense until the grid is like 5% penetrated. And I think that was when California transitioned to NAM 2.0. And once they went past like 12% or 10% of homes
Mhm.
having solar, then they had to go to NAM 3 for good reason. You know, you can't blame them
Mhm.
because it
Yeah,
just like we saw the duck curve. They don't need energy in the middle of the day anymore, and it becomes a
yeah,
problem actually.
yeah,
And
yeah.
so yeah.
And right now, so like this past year in Texas, there's a couple different companies that you can basically get on with. Like Chariot Energy is one of them,
Mhm.
where you can sell back that power. Now it's not necessarily one to one, but it's like, you know, you're gonna laugh at these numbers because the kilowatt cent or the cent per kilowatt is so low. But so you buy it at like 13, I can sell it back at 8. You know,
Okay. I mean,
that's not
with
bad
Texas,
though. That's not
yeah,
bad.
yeah,
So
with Texas Sun, and also with Texas installation prices, which are way lower than California. And don't ask me why. I'll go on for half an hour on that. And I think that the only reason is because consumers are not educated enough, and the margins get wasted in the value chain. Not wasted,
Mhm.
but it just like gets nicely dispersed between all the middlemen,
Oh yeah,
and then that's why we see $2.25 per watt prices in Florida and Texas, and $4 prices per watt in California, still to this day,
that's
when the whole system costs like less than a buck. you
That's
know?
exactly right. That's
Yeah,
exactly right. Yeah. So
yeah.
there's still, I guess what I'm getting at is there's still areas where you can have a quick payback
Yeah.
by, pushing power to the grid. And those areas, they're not gonna, like you said, they're not gonna stay there forever. It's just not how it's gonna pan out, in my opinion. And
Yeah.
that's when batteries are gonna come even even more heavy. But
Yeah.
there's also incentives for people that, just don't want to have a loss of power, right? And we see that as well. But I mean, there's still money to be made for sure. And then there's also those kind of more, I don't want to call them one-offs because there's a lot of them, but more one-offs that are like the data centers, right? That are th- there have been times where utilities basically tell them, hey, it's going to be 2 years before I'll let you interconnect,
Connect.
right?
Yeah.
And they're a data center, they're trying to mine, for Bitcoin or whatever, right?
Yeah.
It's like
Yeah.
I need to be working right now and making my money.
Yeah. Yeah.
um so for those types of scenarios, they'll have, massive PV fields put in, and then a crap ton of batteries put in,
Yeah.
so that way they can
And
continue
this is
going.
already happening right now, is what you're
Oh
saying.
yeah, oh yeah,
Yeah.
already happening, been happening. Those ones are interesting though, because
Are they powering those data centers like purely on solar plus battery and
oh
kind
yeah,
of almost off grid in an off grid manner?
completely off grid, completely off
Wow.
grid, waiting for interconnection to happen. Yeah, like,
But
you
they're
know,
still mining in the meantime.
oh yeah, oh yeah. Think about
Yeah.
it. You start mining, and
Yeah. I mean,
what's
look,
Bitcoin now? Yeah,
I did the
yeah.
math on a simple residential system, like $2 per watt, which I think is very reasonable, even though it doesn't
Mhm.
happen in most scenarios. 90% of scenarios don't hit $2 a watt PV array pricing. And I assumed a $400 per kilowatt hour battery, and
Mhm.
only assumed 85% usage, 15% going to zero, like zero
Yep.
export fee or loss or whatever. And you amortize that over 20 years, you're still getting 6, 7 cents electricity with no cost of financing. Okay, add a 5, 6% cost of financing, double it. You're still at 13 cents electricity, which is lower than the American average for residential we're talking about.
Yeah.
Obviously, if you're doing this at utility scale, the battery price is going to be lower. The PV array system price is going to be, I mean, they're going to be about half. So all these numbers divided by half, you can make them work. There's no
Yeah,
doubt.
exactly. Exactly. And that's the thing. I think that there's still incentives out there for people to, to install these. I think everybody's a little bit worried with the tariffs and stuff coming in, but to be honest with you, I don't think that they're gonna do that much. I really don't.
Yeah.
Um, and the more worrisome thing would be if subsidies are taken away, but I don't think that that can happen either, because you look
Like
at
the
oil.
ITC. I mean,
Yeah,
ITC
like
is really, I don't think the ITC is going to go away.
that I don't either. I mean, you look at
Yeah,
it, I mean, heck, oil has been subsidized for how long? You know,
yeah, yeah,
it's just it's not gonna happen.
yeah,
So I mean, I think that some people are saying they're a little worried and whatnot right now, which is actually
mhm,
not bad because it'll for the short term it'll bring an influx in orders because people
yeah,
are like, oh, I want to get things in, you know, before some tariffs hit and whatnot. Um, but for us, I mean, it's really not
yeah,
going to do that much. You know what I mean? So
yeah. Going
anyway,
back to the
that's what I see
application
as far as the
use
overall.
cases, going back to the application use cases, if I can pick your brain. So
Hmm.
you talked
Hmm.
about the data miners. What about like multifamily buildings or EV chargers coupled with buildings or
Yeah.
standalone EV charging stations? I mean, obviously, Tesla's got a huge, uh, you know, gas station business inside it. Most people don't realize it. That's that they're probably doing 50% of the job outside of homes, let's
Yeah.
say. But obviously, they're not the only brand that's doing that. And
Yeah.
so, do you see any growth in business there and lots of
100%.
demand?
100%. Yeah. So actually, funny enough, our EMS partner, Alexity, um, you know, working with them is great because they also have partnerships with like ChargePoint and a couple of those other big EV
Yeah,
chargers. So we can, so say you have a building and you want to throw in a couple EV chargers there. We can hook our system up and monitor that EV station as well. And
yeah,
we can basically smart monitor it to make it as efficient as possible in conjunction with our battery. So, you know, if it's a high demand time, right, and we can still have some more output from our battery, then we can, you know, help shed that EV charging load off as well and stuff like, I mean, stuff like that,
so
right?
you
But
guys are doing this already in certain
yes,
geographies?
yeah,
Wow.
oh yeah,
Can you
oh
tell
yeah.
me what states you see this? And this happens in like a multifamily apartment setting or a
So
business
actually, you know,
environment?
businesses are
Yeah.
a big one, are a big one because
Yeah.
I mean, you'd have some say you
Oh,
have a
for
car
like
dealership, right?
fleets of vans or things like that.
Oh yeah. Now those ones are even better because they get into the
Yeah.
larger scale equipment. But
Yeah.
for the small for the staying on the CNI, say you have like a dealership or something like that. You know, most of them now have some EV chargers because everybody's selling electric cars, right?
Yeah. Yeah.
So we'll bundle the EV side into you know, well, we won't sell the EV charger, but we'll
Yeah.
essentially bundle the monitoring and the control into the package. And then we can provide that for you. And then we have views of everything, right? From EV, HVAC, PV, our best unit, you know, and we can optimize the
Yeah. Yeah.
essentially the entire system, right? So
Right.
we've done that. Yeah, we've done actually, I was just in California last week or the week before maybe working on that exact scenario, that exact
Wow.
scenario.
For a car dealership.
Yeah, yeah,
Wow.
yeah, that exact
That's nice.
scenario. So
Wow.
but there are the instances where it's the, you know, somebody wants to put in, you know, 20 chargers or something at this gas station and then they want to use a battery. So what they'll do is they'll charge that battery up on off-peak hours, right, when the electricity is cheapest, and then they'll
Yeah.
use that battery, yeah, to help
Okay.
discharge whenever those, yeah, those are being used the most. So, and that's a really common application. We see, I would say that we see, you know, people asking for that pretty frequently. There's some really cool ones out there too, where it's like maybe they have a large piece of machinery that takes a lot of power, and they want to use a battery for that as well. That kind of stuff is pretty, I'd say, pretty common. And really, in that type of scenario, it's just about the battery covering the load of the vehicle. So, I mean that cent difference or the couple cents difference in when you take the power in versus when you push the power out becomes big bucks, right?
Yeah.
So
No doubt. Yeah. So yeah, like we said, there's going to be a lot of optimization opportunities at a micro level.
Yep.
And we're gonna need these VP of energy optimization in many and
That's
they will be
exactly right.
using systems like the ones that you're providing.
Yeah.
So as we near the end of our conversation here, Jayson, any parting words or comments or wishes from the universe for what you'd like to see happen as we enter a new administration, and talked about
Definitely.
tariffs and China, US. You obviously work for a Chinese company too, so
Yeah.
like
Yeah.
you know, any last thoughts that you want to share?
You know, man, I mean, I love working for CPS. They're fantastic. The only downside of working for a China company is this, 1 a.m. meetings every once in a while.
Yeah.
No, they're not. That's not bad. That's not bad.
Yeah.
No, it's fantastic. And I'd say the only wish that I have, for the future moving on is, and it's already kind of been happening over the past few years, is that people, learn more and educate themselves on some of these benefits. I think that a lot of people now know of solar and of batteries, right? Solar more so than batteries. But I think a lot of people are still scared of them. I mean, you have
Yeah.
some horror stories, right? Like LG back in the
Yeah.
day,
Yeah.
stuff like that. We're in such a better place now as far as the technology goes and what we can do with that technology. And I would just encourage people to educate themselves. And if they have any questions at all, please feel free, reach out to me. My email is jason.smith@chintpower.com. The Jayson has a Y in it, so Jayson. Please reach out to me, and I can help answer any questions that you have regarding the PV side or the BESS side, and hopefully show you that the systems are not only they're safe and they're not scary, but they can also provide you with a little bit more money in your pocket if you do it right. So yeah.
Jayson Smith, thank you so much for sharing all your knowledge and wisdom in this area. Thanks again, and hope to repeat this in due time.
Definitely, definitely. We'll have another one where we dig a little bit more into the technical stuff.
Awesome. Thank you.
Perfect. All right, have a good one.
Thanks.